And what I'm trying to do is to sketch out a few elements of what the public policy of human settlements is in the context of climate change, and drawing a lot from your contributions, and put it out for discussion. So first, why? Like the first thing is that, and it actually, now I realize it's already addressing Kai's question to a little degree. Cities may be agents of climate action, especially when nation states fail. Like there's a Nature paper, just a comment saying that when US government under Trump didn't move forward anymore on climate change mitigation, it was cities that were stepping in. So that's like the first part where they come in. And of course, it's not only like substituting for nation-state action, but it's also for complementing nation-state acting. And this is realized by the IPCC with now the second report addressing this. Second thing, it's like what's happening now is, and why this is a game-changing situation, we have now big data available, and that allows to have like a scalable approach for place-based solutions. Okay, it's a big thing to say. I don't expect you to follow me in 1 second, but I will talk later in my, about it in more detail. And the third thing is like cities are really for people, like it's by and for people, that's where people are living. And that's why, of course, it determines our lifestyle. It's important for our life, how we feel, for our quality of life. And that means like as participants in cities, we should have a say how climate solutions are implemented. So these are like 3 big starting points. First hypothesis, people-centric design is a climate-friendly design. Okay? People-friendly design, human-scale design is a climate-friendly. So where does the human scale come in? Like the architects among you know the story very well. It's coming from Jan Geels, who wrote this book, City for People, who as a reaction to the modernist movement of the 50s and 60s realized that a psychology perspective on buildings, on street space design is really important, because that's how you grasp what people really, how people interact with the city. And his main point is it must be human scale. That means it must be designed for speeds of 5 kilometers per hour. It must be linear in terms of like for feet, for walking. But you also want to have plazas, like where you can move your eye. You can see with the eye into some distance, possibly you can see something. And it also means make places small. So for example, in this room here, it's really designed for 35 people. It's not many actually for a conference, but it feels intense enough that we have engaging discussions. If you would be in a big room for 200 people, the 30 or 35 people of us, it would feel like, where's everyone else? Nobody's here, I want to go too. So like, makes places small, it helps engagement and interaction. So one point is, it's not, it's also like one perspective like where you can underpin this. This is a paper where we looked into ethical design principles, like ethical design of street space allocation, looking at different abstract philosophical theories of ethics, like utilitarianism and so on, and the y-axis are different street space allocation principles. And the red ones are where both interact. You can see the second last one, that's interacting most. There's the most red spaces, and this is really the perspective of street as a place. Okay? When we see street as a place, it has the most overlap with most ethical principles. Of course, you can't design streets only as a place, but it's comprehensively under-designed as a place. And just what's the consequence of these kind of approaches, and actually does not really depend on what kind of allocation mechanism you choose, because it goes all in the same direction. There's an unfair distribution of street space, and it's mostly unfair in terms of, okay, pedestrians need a bit more, cyclists need a bit more, and it's actually not the moving car that's the problem, but the parked car. Because parked cars take a lot of space. So that's from a street space fairness point of view. grateful for Timothy to introducing us to Robert Moses and Jane Jacobs. So you know the story already, and I think it's really the big story here. We have the story of where actually buildings and transport go together. And that's like the really, really big point. You can't actually think about a transport system and a settlement system independently. They always go together. And what happened was modernism, which was about big, tall, singular standing buildings and big streets in between and parks in between. That was the modernist theory and actually implemented theory of the 50s and 60s. That was what Robert Moses did. So actually he built, like, actually was successful in some highways through New York. He failed for Greenwich Village, where Jane Jacobs put her foot down. So the opposite intervention is of Jane Jacobs, which is really also about this human scale. You want to have interaction on the street. So you want to have diversity. You want to have like different sort of glass like fronts on the street. You want to have people interaction, which is not about meeting friends, but you want to talk randomly, shortly with people on the street, for example, buying a newspaper at a kiosk. You want to design streets accordingly. So there's a larger story behind it. It's not only about, I mean, like this is a story, but it's really about like a larger perspective of self-stabilizing systems. The one system is the technocratic system where you have like modernism with the large-scale buildings and the highways in between, which leads to systemically to car dependency. And you have supporting side systems that support this car-dependent system, which is about car industry and car culture, which supports different aspects of the car dependency. You have highway construction industry, and you have specialist investors and architects supporting each part of that. And because you have this large ecosystem in different parts that are really aligned, it becomes self-stabilizing. It can be also the other way, like where we have a human scale housing, walkable streets, urban well-being focused, where you have a thriving civil society which supports the existence of this urban well-being spaces. You have perhaps also specialist investors and architects that are really focusing on this human scale housing. And you have a diverse service industry which coordinates with the walkable streets where there's a lot of interaction. It's a little bit of a fable story, and of course we shouldn't be like too easily follow those two. So the question is really like, is it like so positive as so negative? Probably it's not. There was, of course, like the rhetorics of the 50s. Of course, Robert Moses was not just saying we are destroying the city. He was saying, no, we are actually refurbishing the slums. That was his story, right? So the refurbishing slums sounds much better. So like perhaps there is something in that if we have just hyper-local villages, which are very nice to live in, but we are also benefiting all from mobile spaces where we can go to other places. So it's probably really a perspective of getting some aspects together. So what does it actually mean? And we now go to the harder metrics of climate change mitigation. So what's this graph here? It's really showing it's from the SPM of the just published IPCC report, and it's let's look at this. It's land transport and buildings, and land transport and buildings. There are CO2 emissions happening. This is basically about human settlements. The human settlements emissions are mostly in land transport and building. They're a bit on waste, of course. You can also think about larger perspectives for energy use, but really that's where the most interaction is. So we have this amount of emissions in 2050, and they can go down by about 2/3 each in land transport and buildings by demand-side action only. So what's demand-side action? It's basically what we're talking about. It's not talking about decarbonizing the electricity system, because of course that's what we need. We need renewable energy, etc. So, but that's not the perspective of the settlement. So this is something that needs to be done by here. But if we go into behavioral change, if we go into infrastructures, infrastructure provision at human scale, but also in terms of end-use technologies, and that actually involves, of course, the electric car, and then we can achieve 2/3 of reduction. And Kai, if you can have a look here, so this is the best guess what the IPCC says, what's possible by electric cars and land transport, global emission reduction. I'm not talking about Germany, global emission reductions in the land transport sector. And this amount is not going to zero. And the idea is that essentially we are on a time scale where we can't rely only on electrifying transportation and building. So it's indeed, it's actually, and you are right about that, it's perhaps the most important strategy. And it's a good focus to have it. So perhaps actually a very important policy for Berlin would be to ban all combustion and diesel engine starting 2030. In the inner city perhaps only. It might be the most important policy, but just announcing it, nobody in Berlin and Brandenburg would buy a conventional car anymore. So like that's maybe the most important one, but Kai, it would not be sufficient. That's my point. Okay. And there's another reason, because these kind of solutions that are working on a human scale, they are consistent with human well-being. They're improving human well-being. They're doing in a number of metrics. This graph has 18 different dimensions. The most important may be health and it's life expectancy. If we go, like and I'm just focusing on cities now, if we go into one strategy which is moving more by walking and cycling, we can increase our life expectancy in statistically by at least half a year, if not 1 year. It's a huge margin, and we live a healthier life. So active mobility, which is not the largest part in mitigation, in fact, it's not. It's a small part that contributes to mitigation. It's very important in terms of public health, and it's a measure that is small part of the overall solutions, but we need many small parts, and it's a very nice part because it actually improves our lives. So we shouldn't neglect this. Okay, so what makes it? What's the governing of the contested spaces? We have actually a problem, and the problem is that we have this huge complexity. So like I'm making now a bit appetite because tomorrow morning we have a keynote by Rob Sokolov, who is one of the founding fathers of environmental sciences. He's now, I think, 84, and in the 70s he wrote like this amazing book and participated in contested values, and his contribution was on failures of discourse. And what they did back then was investigating a dam project in New Jersey. Building a dam or not. Sounds easy, it's of course quite complicated, because then there's the engineer perspective who are like, okay, what material do we need? Then there is a perspective on the flow, how much through flow of water do we have? There's a question of the recreation, because there was an argument, oh, if we build a dam, then it's a lake and it's better for recreation of the citizens who can do a weekend trip there. There's of course the ecosystem perspective, what happens with the upstream and downstream flow, what happens to the oyster farmers downstream. So everyone has their own perspective and their own metrics and looking at that. And so like just observing that, it becomes a fantastic plethora view and a huge disagreement of what even to look at. Because, so like there came, and Rob Sokolov made a few observations. There's a lot of golden numbers and golden rules, because you can't handle the complexity. You come up with a number. For example, someone said once, oh, you need to have a through flow of water of at least X meter of water a second in this location. Someone said it for some reasoning. And then it was fixed in a document, and all documents survives. We need to have this through flow number, though nobody really understood why. And you have it also with the rules, like in terms of like what should be done. And so what I'm saying is, in these kind of objects that we are concerned about, and of course cities are those, they are open systems. They're interacting with many different aspects, with our mobile life, with the way we are living, with a lot of governance questions and business questions at the same time. And that makes it difficult to just say, oh, I have this discipline, I know what to do, and we are done. So we have to interact with that, and we have to be beware of shortcuts It becomes really a intellectual exercise. I'm really thinking we need to approach this intellectually, and we need to approach all disciplines, because we, of course, need to understand the numbers, like just coming back to Kai, we need to understand that electric cars are perhaps in the mobility system the largest chunk of the solution. Like if you forget that, that's really stupid, right? So we need to think about it. But it's one of my favorite papers by Moshe Guvoni on smart mobility sustainable? Because what he did, he asking like 175 engineers, I think, who are working on smart mobility. Do you think your smart solution is sustainable? And basically everyone's saying, yes, of course, it's smart, so it's sustainable. And of course, it's not. Like you can build a lot of very nice technologies, right? And it makes it sometimes a little bit more efficient. Sometimes it's like it makes more convenient, and all of that is fine. But the sustainability question has to consider a number of different dimensions. It has to look for a systemic impact, for example, rebound effects, etc. And of course, it also has to look at the task at hand, and the task at hand is like reducing emissions until 2050 or perhaps earlier, like globally, to zero, which is a gigantic task, which you can't solve by marginally playing with a technology that has a lot of scaling impact at the same time. Of course, all of that can help. I'm not talking against smart mobility options, not at all. I'm a fan of a number of those, but just getting this into a context, that's really important. There's an advantage, though. So I made a very complexity story up, and I made say it's very, very difficult, and we need to think hard about it, but there's an advantage because we're talking about cities. We're talking about places. We're talking about specific places, and on these specific places, all the complexity boils down. And then you can talk with the stakeholders at the place. You don't have to solve it in a very generic way for all kinds of circumstances, but you can really go to this street or that building and see what the interaction is and try to move forward. So that's really possible, and that's what makes cities actually workable. Okay, so three questions to answer. The first question is who does what? The second is how? And the third, I will see. It's a work question, like where do we actually do that? So what do we have to deal with? This is like just looking at three regimes. These are the emissions of the current cities here. The blue one are the emissions of the cities and places that we are building up. And the gray one is, the gray energy is really the construction side. So I'm very happy for your contributions, Eike, because I think that's a really important part. If we just continue constructing, a lot of emissions are in the construction itself. And it's another reason to think about systemic solution, because if we address everything by electric cars only, that it probably means we need a lot of more construction of new buildings in the countryside, which is a lot of emissions here. We have to think about stocks, the emissions embedded in stocks and buildings, and also, of course, in cars. So we have to think about what we're building now has impact until 2050, and we have to think about the building itself. That's the main point here. Transport systems rules. What I'm meaning here is, I said before, there's a lot of interaction between transport system and settlement systems, and there's causality going into both directions. But I would argue that a bit more of the causality is coming from the transport system. It can be seen like if you take, this is urban economics all about, like this, it basically has one equation, urban economics. Can look very complicated, but there's one equation that basically says if you decrease marginal transportation costs, which is the amount of money you have to pay for a liter of gasoline at the station, if you decrease the cost, people move out. It becomes a flat city, a sprawl city. If you increase the price, it becomes denser. And of course, this has repercussion effects. For example, for public transport, you need certain customer density. You can't have public transport in a very low dense settlements. You need like a certain amount of people who are driving at the same time the same car. That's what you need. And you need distances. You need smaller distance if you take a bicycle or e-scooter. With an electric bike, you can go perhaps now 10 or 15 kilometers, but you can't do 30, 40 kilometers away. That's going too far. So you have this repercussions effect in that direction, and it's really the main point here is that this is the fuel price here. It has highly nonlinear effect on induced CO2 emissions. This is only transportation, but of course it has also extremely high impacts on the building emissions, because if you have more dense settlements, you have lower floor space per capita, you have more public space where you use the facilities, and that means like the transport system has impacts on the CO2 emissions in the building sector. That's another main point. Okay, so what we need to do to design these cities is really to gather the design and planning sciences, and of course the social sciences, governance sciences, and economics around a common agenda. And that is because there are, of course, many are motivated to do and research on climate change, but the interaction effects are important. The one story I was telling about the interaction between transport system and building system, but there are, of course, many more of those. And the interaction effects are important, so it's important to gather around and really talk to each other. That's the main thing. So I'm not really talking about solutions, but I just want to point out two main strategies that are important. It's about retrofitting the existing building stocks, about the heating and cooling technologies in buildings. It's about construction, or perhaps not construction at all. It's about floor space distribution and the design issues that are associated with that. Still underappreciated part of the solution. Mobility, it's like one of the main points. Like, we know that it's always nice to talk about the new nice thing. It can be everything. It can be any sort of public transportation, shared mobility, e-scooters. It can be, you can just think about anything nice, and people are fascinated by that. But if you go into modeling, you always see it has on its own a very small impact on greenhouse gas emission reductions. You need to additionally have a push instruments, which can be, usually in economics it says, a city toll, greenhouse gas emission in transportation, but it can be in cities just parking management. So you have to have both of that at the same time. And of course, we need to consider electric mobility, and in cities like Berlin, it means to have the charging poles available so people can charge their cars, which is the urban contribution perhaps to that. Planning is part of that, to coordinate that, and of course there are a number of cross-cutting issues, like really informing and understanding, like that there's not only a few academics who understand it, but that it's a lot of interaction and mutual learning happening. The relevant stakeholders must be put together, and also issues must be addressed, like that there are lack of skilled labor, which may be one of the biggest barriers currently in issues like heat pump rollout and similar issues. So where do you actually do that? And that's the part I alluded to at the beginning, that by now we have urban big data available, and the full difference is now that we don't need to talk anymore about generic solutions like, okay, let's do transport-oriented development, like a strategy that we know that is useful, but we can now use the existing data to say we do transport-oriented development in location A, in this kind of scale, and that's perhaps according to this kind of boundary conditions, the most lowest CO2 emission development that is possible. So like the story here is that by now this data is in principle available. We discussed it. There are a lot of barriers. We need to, we perhaps don't want all data. It may be problematic. We may need some specific data that are actually available. So we have to talk about all that. We have to talk about ownership and access of data. But in principle, at least some of that is available. So that's, there are two aspects to that. One is a global perspective, and one is a hyperlocal perspective. So here's the global perspective. By now we have availability of data on cities worldwide. We can compare cities on these data, and we can typologize them. Typologize meaning really sorting them to which city is most equal. Of course, like if you are inhabitant of a city, you always say your city is special, and it's true. Every city is special. but some cities are a bit more similar to each other than to other cities. And you can make use of that. So you can sort them according to certain properties, mostly on an economic level, on urban planning level, on urban form. You can think about climate conditions, and we know that all of these conditions are really important in terms of shaping the greenhouse gas emissions and the structure of greenhouse gas emission behind it. This typology of, I think, 274 cities worldwide, and there are 8 different types of cities. They are sorting according to the nonlinear combination of GDP per capita, of population density, of fuel prices, and of HDD, which is heating degree days, is local climate condition. And you can see, for example, this is the energy per capita here. You can see that type 13 and 14, they have similar energy per capita, but they're different types. Like this one has high gasoline prices but low heating degree days, and this one has low gasoline prices and high population density. So they actually, if you just observe the energy use in greenhouse gas emissions, they look similar, but actually the reason, the causality behind that is different, and this kind of methods can help that. And by this, if you know that in some cities in type 13, this policies worked well, you can look at the other cities in type 13 to look whether you can copy from that. That's like the basic philosophy here, that you actually can use big global data to add a little bit advanced scalability. Can then go scale this down. This is an example of London, like with many different districts, and you can combine it with a lot of socio-demographic factors, where you can additionally define and identify district-level emission patterns according to the drivers of emissions. So, for example, here you can very rapidly identify where housing stock is very old and needs renovation, where this is the most important part, and others it may be more mobility-related. Can combine then also like this typology of cities, which is the upper part of upper right part. It's reproducing the former city figure in a different way. You can combine this typology of cities with the insights of the literature that have case studies on these cities. So you can, like, if you say, like, in type 13, there is the city of Seoul, Korea, then you can identify with a big literature data approach all case studies on Seoul, and look what these case studies about Seoul are saying, and compare it also with the case studies of the other cities in type 13. So you can have really much more systematic approach, both on big data on a global city level, but also on literature. Combine that, really scale things up in a more systematic way. Of course, if you look at the case studies, most are rubbish, so it's like not easy to move forward quickly, but at least you have a systematic way to approach this issue and actually filter what's most useful. So then you can go into cities like Porto here. I think it's one of the most underappreciated studies of recent years, Mafalda Silva's study here. The idea is that if you have housing and street level energy use and greenhouse gas emissions, if you have that, and you identify with in this case, an artificial neural network, with basically call it artificial intelligence to make it short, you identify the underlying form patterns that drive emissions in housing use and in transportation as induced by urban form and other parameters. And then you identify the pattern, then you can use it for predictive modeling. So you know now what the specific context-rich drivers are, and you play around with a city plan, you make a densification, a consolidation, a transport-oriented development, multifamily houses outside, and random development, and you just put it out on a map, and you simulate by predictive modeling how many emissions are occurring here. And I think that's what you can do when you have the big data available, that you can do very rapid urban planning estimations. This is for Berlin. Felix Wagner's study, who will present it tomorrow, really like identifying urban form matrix inducing greenhouse gas emissions at specific different locations in Berlin, so it becomes not a statistical exercise but a context-specific exercise, and you can correlate it with socio-demographic variables such as income. Here's high income, car dependency, high income. Here's car dependency and low income, so you know, have a better intuition where actually to interact also with the social problems behind that. Okay, let's come to the last part, how. 4 different aspects. So it's really about governance. we talked about this morning, so there is much more richer information than I can present here, but one important part, of course, is polycentric government, and here, perhaps in support, in this case, of Kai's intervention, yes, we have to understand that the biggest chunk in emission reduction is the electrification of both housing and transport sector. It's about heat pumps, and it's about electric cars, and that's a template also for urban action, so we really have to see that. And actually, just to see that, a lot of legislation of what can be done by the city of Berlin, just to be specific, depends on federal legislation. But the city of Berlin has opportunity to put actually legislative processes in place by the Bundesrat. So like that may be a really important point here. And of course, it's known, but that's like this polycentric governance, it also goes the other direction, is an important one. I apologize, one of the arrows is the wrong direction, it should be circular. This is like involving a wide set of actors. We also talked about it widely, and you can think about like here the Bürgerrat, the Berlin Partner which support business, then there are citizen data scientists, all of them. The interaction here is in interesting ways because, for example, we know that infrastructures are really important. So if municipalities have more cycling ways, etc., it has an effect. People change to cycling. We know that. But also like people engaging more in cycling, they have a social group effect. There are some theories, and they're actually not really well empirically founded, but they may still be true, about social tipping points. And one social tipping point is like typically coming from the public health science, 15 to 25% of people engage in one behavior and it becomes like widely socially acceptable. Same true with cycling. Like if you see more people cycling, you also do it. It's a social contagion effect. And you also have a social safety effect because we know that cycling is safer when you're engaging in a group of cyclists. That's also true. So there are actually at least two different dynamics which make it socially supportive to cycle more, and that interacts then with the infrastructure domain. I think it's a really cool research question to go into that. It's very hard to operationalize in good data. Okay, in third point about governance, administration, we need to get administrations working. It's one of the hardest problems of all. It's like if you talk with administrations or people who are motivated, it's you hear stories you can't imagine. It's I mean, like for example, the city of Schöneberg has a transport planning department, and 12 positions for personnel, and there's none occupied. They don't find people for it. Like starting point of the problem. You don't have people. Then the second problem, not educated for task. Like they have an education on road design, but not on bicycle planning, though the only thing they want to do is bicycle planning. You have hierarchical positioning, which is difficult. Administrations are hierarchical. You need management delegation on lower levels, but upper levels don't want to give it up. Problem, next problem. You have a veto power, because usually you're not talking about one administration, but 3, 4, 5, or even more. If you have like a process like you want to go down to the street and open one parking space for a tree. You want to plant a tree instead of a parking space. I think it's a straightforward thing. No, you basically have to talk about like 12 to 15 institutions because you actually don't know what kind of cables are below the street. There's no coherent database for that, so you need to ask each individual organization like telecom, like water, whatever, what do we have under this position under the street? And like asking a specific institution can take 3 months just for one of that if you're optimistic. So next problem. It's also a database problem to partially. And of course, there's a fear not to follow procedure. So like one of the secrets is some parts are, I mean, like it's amazing actually, though there's these barriers, streets are changing in Berlin in some instances, and if you talk to them, they are really saying we're doing illegal stuff. They're really scared about being sued because they're actually not following the procedure to the last point. If they would do, they would never realize anything. Okay, so like I don't have the answer to that. It's one big one, but there's this Creative Bureaucracy Festival that was alluded to by Julia and Nicole this morning. So it's just tapping next door. It may be really important actually. It's about the legal code. Legal code is very important, like the Straßenverkehrsordnung in the German case. So you want to actually localize or have legislation that supports action by cities, and you want to experiment, because experimenting is the way out. So if you have to follow all the procedure to install something, if you just say, I'm doing an experiment, then you have a bit more leverage. And the administrations actually understand that and going into that direction. Last point on governance, it's the data governance point. Don't ignore the details, but the main point here is that there's a physical infrastructure and there's a digital infrastructure. And the historical governance of cities is about the physical infrastructures of spaces and places. And what we are having now is there's a lot of data available on these places, and the question of the ownership of access of data and how to do that may become an urban one. If it's not actively managed by cities, there will become other actors who will invariantly take this over, and because of the power they have with the data, also will have power over cities. And it's really important for cities to engage in one way or the other with that. Okay, last concluding slide. One of the hypotheses is really to embed the climate governance into other urban objectives like education, urban digital sovereignty, and public health, to see the connection points here, because a lot of action is happening in each of these domains, so why not to connect and align? That's the summary then. Cities are for people. Building and mobility at human scale contributes to climate change mitigation and makes life better. And there are 3 tasks ahead. One is like getting all the disciplines that are here in the room together to combine about an agenda of urban climate action, to scale solutions that remain authentic to the issues of the specific place, but still scale them with different approaches, inter alia big data approaches, and then coordinate different agendas that in some way often overlap. Many thanks for your attention.